Hi teachers of Junior STEM. This video is for us to be able to provide some considerations for assessing 3D models. Again, thank you very much for taking this subject. There is a lot of scope for our students to do really well and be able to present their ideas in a very creative manner. But of course, there needs to be consistency surrounding how we assess students on the 3D models as well. And I'll just very briefly touch on the actual task itself. So we'll go through a couple of dot points there. It won't be too long of a video. So the overview of the assessment criteria, the important thing to know regarding this particular CAT is that we don't assess students purely based on, for example, the number of marks they get or the number of questions they get right, but more so whether they're demonstrating the skills that are aligned with the achievement standards as provided by the Victorian curriculum. And so the main things that we're focusing on with our 3D model are technical accuracy, creativity / originality, and functionality. So we'll start with the technical accuracy aspect. The first part of this is to check the model to have correct dimensions and proportions. Oftentimes we have students misunderstand how to create a fan blade. Now there is an aspect of the task where we present students with examples of fan blades and fans. However, oftentimes we get students with massive fan hubs in the center and then also these tiny blades, or they'll have the direct opposite where they'll have these massive fan blades and a hub that's not able to handle that. So of course, that conversation needs to come in when we have our discussions and reflections on how we iterate and improve our fan blades. So yeah, as I mentioned, checking for the correct dimensions and proportions. The other thing is, yeah, as I mentioned, a lot of students end up just having very small fans that just aren't able to pick up any wind and therefore are not able to really achieve high energy readings that they should. So again, proportions need to be done, preferably beforehand, before they submit their model for 3D printing, and actually just comparing the values they get, understanding that the values that come up in here are in millimeters, and know how to change that into centimeters and visualize that in real life before printing. The creativity and originality aspect surrounds the evaluating the design for innovation and originality, as I mentioned before. So of course, this in itself is a very common fan blade design. Sometimes we have students use the scribble function. So they'll put this down, they're trying to draw a fan blade that is slightly tilted, something like this, so that when they put it into their design, they, instead of using this fan blade, they use some sort of curved fan blade and then tilt that as well, which is a great idea, and honestly in my opinion it doesn't work half the time purely because it's inconsistent, but it absolutely can, and it demonstrates their thinking behind that as well. And it really, what we should be doing throughout this design thinking process is to encourage the creative problem solving and unique approaches. So if they decide to do that, absolutely. Sometimes you have students apply, for example, a multi-tiered approach where they will have something like this and then they'll duplicate that and rotate that outward. So it'll look something like this. And it's just so that way the students end up with a two-layered fan blade, and sometimes it works better, sometimes it doesn't, but the difficulty there is in making sure the fan blade works as designed, which leads me to the final point about functionality. So the last thing we really focus on in terms of the 3D model is assess it for the intended function. Now we do get the students to measure the energy output and whatnot, but while it's not a failure success situation, it's more so whether they've demonstrated some sort of thinking into their design beyond just make a fan. And so if the fan is able to function correctly, amazing, then how can we improve on it? And those are some questions, those are some things that the students should be answering in the document itself. But if it's not working the way it should, how do they improve on it? So for example, if the fan blades are too thin and they're breaking off, or if the fan blades are too thick and they are absolutely just adding way too much weight to it and it makes it too difficult for the fan to move, how do they improve that design for next time? So those are the three key things: technical accuracy, creativity and originality, and then the functionality as well. And then in terms of the actual CAT or the assessment itself, we're looking at the presentation, documentation, the collaboration and teamwork, and then the reflection iteration aspects. So in terms of the presentation, importance of clear and detailed documentation of the design process. Students are guided to answering questions in the discussion section to make sure that they're actually demonstrating the knowledge. Another aspect of that is to make sure that they're clearly understanding and recognizing success criteria. For example, it's not just the fan works if it turns, but the fan is successful if it's able to generate an output of X amount of kilowatts, or it's able to turn at a high speed without breaking apart, something like that. So beyond just the it works or it turns aspect. We're also evaluating students' ability to explain their design choices and workflow. So why did the design decide to go with this shape for a hub? Because they're not limited to a cylinder hub. Ideally, they would use something like this, where it is a paraboloid, where the wind would be more likely to pass through into the blades as opposed to into the hubs. Now, if we can get the students to explain why they would have used that instead, that would, of course, demonstrate their knowledge of the Victorian achievement standards there as well. In terms of collaboration and teamwork, students, there is an aspect of the task that requires them to be working in groups. That may be changed for future assessments, but of course that collaboration, communication, division of tasks is important for us to be observing. And then finally, the reflection and iteration. So encouraging students to reflect on their design process and final product. There are, again, questions on how to improve that final product and ideas to get them to identify improvements and iterate on their design if they were to do it again. So really a strong emphasis of this task is to really push through the iteration. Oftentimes we get to the stage where we prototype and they barely test, but if we can get students to also iterate and perhaps make another design on top of that that works even better than the first one, that would be amazing. Okay, that's about it. Please let me know if you have any questions, and best of luck with assessing this CAT.